Hello everybody. This is Samuel Choi from IRM Korea. I think it is a great honor to be here today to introduce Korea's Health Information Exchange System. To help you understand, today's presentation will be assisted by an artificial intelligence voice, not my own pronunciation. In today's presentation, I will introduce the Health Information Exchange System, which is operated by Korean government. Also, I will explain the purpose of the system, the development history, system architecture, and how it will be used in the future. Before going into detail, let me briefly introduce myself and our company. I have been working in the field of medical devices and medical IT systems for about 30 years. As a co-founder of Infinite Healthcare, I have experience in starting and growing several medical device companies, medical IT companies, and even surgical robot company. IRM is a healthcare IT specialist that develops solutions for the acquisition, integration and utilization of various kinds of medical data. Based on healthcare standards such as IHE, DICOM, HL7 or FHIR, we have developed many solutions and services for securely and easily use sensitive healthcare and medical data, and we have performed many domestic and international businesses and projects in various fields. The Health Information Exchange System developed based on our technology and experience is showing remarkable results as a result of Korean government's medical infrastructure improvement policy. Now, let me tell you more about Korea's Health Information Exchange System. Health Information Exchange is a system that plays a role in activating the medical delivery system and ultimately improving patient care by exchanging medical information such as diagnosis, medication, examination, and treatment among medical institutions. So far, in many cases, medical information has not been well shared or exchanged among medical institutions. As a result, there were problems like duplicate prescriptions and duplicate examinations, resulting in inconvenience as well as misdiagnosis. Health Information Exchange can connect disconnected healthcare through data integration and exchange, reduce medical expenses, provide better healthcare services, and distribute workloads between hospitals. I will briefly explain the history of Korea's Health Information Exchange System. From 2009, the medical terminology system began to be standardized, and small pilot projects were started centered on hospitals and clinics in the metropolitan Seoul area. In addition, in 2016, Korean Ministry of Health and Welfare announced the standard for health information exchange, where document forms, data formats and communication protocols were standardized. In 2017, the Medical Act was amended to allow exchange of health information, and it was expanded to the main project beyond the pilot project, and image exchange was also included. After 2019, not only medical institutions but also other national institutions such as Workers' Compensation and Welfare Service, Health Insurance Review and Assessment Service and Military Manpower Administration have been linked to exchange health information and medical images. This figure shows the overall configuration of the Health Information Exchange System. Participating medical institutions are on the far left, and they are connected to the regional hub medical institutions. Document repositories are established at the regional hub institutions. The most essential part is the third part, where the document registry, master patient index, patient consent management, image storage and patient portal are located. These data are linked not only with medical institutions, but also with other national institutions such as the Health Insurance Review and Assessment Service. Currently, more than 6,800 hospitals and clinics, including 40 regional hub hospitals across the country, are participating in the Health Information Exchange System. Document data are stored in distributed data repositories, but image data is centrally managed. The data of patients, who have visited the primary clinic or secondary hospitals, are transferred to the tertiary hospital, and after treatment is completed at the tertiary hospital, these data are transferred back to the primary or secondary institutions to receive the rest of the treatment. Of course, patient consent is essential at each step. The MyChart service portal has been opened for user service, and the service is provided in web and mobile environments. Users can provide patient consent or view service usage history. As one of the incentives to promote the health information exchange, the exchange of medical information is now being reimbursed by the National Health Insurance. For example, when a clinic sends a patient to a tertiary hospital, about $10 is reimbursed. At this time, if the clinic sends the patient documents digitally through the Health Information Exchange System, additional $4 is reimbursed. If the clinic also sends the medical images with Image Exchange System, another $4 is supported as well. Through this kind of reimbursement plan, we are activating patient and data exchange between hospitals. Let me explain a little more about the technical stuff. In order to integrate medical institutions using different kinds of hospital information systems, we have utilized as many healthcare standards as possible. Not only the well-known IHEIT infrastructure profiles such as XDS.B, patient identifier cross-referencing, patient demographic query, document metadata subscription, basic patient privacy consent, audit trail and node authentication, but also cross-enterprise basic e-referral workflow definition profile are widely used for health information exchange. For image exchange, XDSI.B and access to radiology information profiles, several DICOM web standards such as STORS and WADO are also applied. This figure shows the overall architecture for health information exchange. As explained earlier, it mainly follows the concept of the IHEXDS document sharing system. On the left side of the figure, at the sending hospital, a consolidated CDA document containing the patient, medication, examination and image information is created and then stored into the document repository in the regional base hospital. According to the XDS.B standard, the document metadata is stored in the document registry in the center. On the right side, at the receiving hospital, the exchange document is searched at the document registry and retrieved from the document repository after getting the document availability notification through DSUB profile. Image exchange part is basically designed based on the IHEXDSI.B profile. DICOM images are queried and retrieved from the PACS at the sending hospital, and uploaded to the image repository using DICOM web services. And then, according to the IHEXDSI.B profile, DICOM COS manifest is created and registered to the document registry. At the receiving hospital, the COS manifest is retrieved first and then each DICOM images are retrieved and imported to the PACS of the hospital. Currently, 6 types of documents and DICOM images are exchanged in the system: referral note, transfer summary note, consult note, summary of episode note, diagnostic imaging report, patient consent document, and DICOM image files. All of these documents are standardized and exchanged in the HL7C CDA format. Medical terminologies are also standardized. For disease codes, we are using KCD7, which is an extension of ICD-10. For drug codes, we use KD, which means Korea Drug Code. Also for procedures, we use ICD-9 Following the IHEXDS document sharing model, the Health Information Exchange System is composed of one document registry in the center, and multiple document repositories in regional base hospitals. However, image data are centrally managed in the center. For patient identification, we also created a separate master patient index which can be mapped into each hospital's patient identifiers as well as the patient resident registration number. When establishing the nationwide health information exchange system, the most difficult part was the interface with the information systems of each hospital. This was because hospitals in Korea rarely use hospital information systems that comply with standards such as HL7 etc. Theoretically, each hospital or IT company had to implement the interface of the Health Information Exchange System by themselves, but in reality, it was difficult or almost impossible. So, we had to implement and provide interface modules in various languages. For the EMR vendors or medical institutions, interface software has been developed in various kinds of programming languages such as Java, C#, Delphi and even VB and PowerBuilder, etc. This kind of interface module is used to convert proprietary format of data to standardized ones, or vice versa. Regarding the image exchange, DICOM images can be viewed directly through the DICOM web viewer built into the medical image exchange system. Of course, the images can be downloaded and imported into the hospital's PACS. So far, I have given an overview and technical details of the Health Information Exchange System. Before wrapping up today's presentation, as a person in charge of operating the nationwide Health Information Exchange System for the past 5 years, I would like to tell you a few more about my opinions and the direction I need to take in the future. The current Health Information Exchange System in Korea was developed so that medical records and images can be exchanged electronically between medical institutions, focusing on improving the medical service environment for all citizens, and increasing the work efficiency of medical professionals. Compared to the past when patients carried paper documents or image CDs, the current HIE is a much more advanced one. However, there are still limitations in that the scope is very limited. Currently, the data exchanged in the current HIE system is limited to only 6 types of CDA documents and radiology DICOM images. As we all know, health data includes not only clinical data, but also claims data, research data, genomic data, patient-generated health data, etc. Currently, the data exchanged in the Korean HIE system is only a small part. In the past, PACS, as we know it, was used only for radiology images, but now it has been evolving to enterprise imaging system to manage more diverse types of image data. I think that in order to achieve the ultimate goal of health information exchange, an extended type of VNA is required, where we can integrate not only image data but also various types of health data including genomic data, PGHD, or others. I would like to call this kind of generic data platform a CNA or Content Neutral Archive. In this regard, IRM has developed a generic data platform that can integrate, manage, and utilize various data in cooperation with domestic university hospitals. What we call Enterprise Data Platform is our Content Neutral Archive that can integrate a vast amount of diverse type of data such as images and pathology data, as well as various lab test results, genomic data, biosignals, PGHD, IoT data, and others. It includes a universal viewer that can show integrated data on one screen. The Enterprise Data Platform is currently being used for AI research and clinical trials using medical data, and it is planned to integrate more types of data and be used in more diverse fields in the future. We believe that if a system such as the aforementioned content-neutral enterprise data platform is built in more hospitals, a next-generation health information exchange system that can integrate and exchange more diverse health data can be accomplished. This concludes my presentation. Thank you for your attention.